Okay, these are, we're still talking about section
14.3.
correct, 14.3. And so today we're going to finish this section up and then get started on something else. So we're going to focus on, right, these equilibrium calculations. And these are indeed the lecture number 11 slides. And so we're going to look at InClss number 21. And this is a base equilibrium. How do we know it's a base equilibrium? I'm asking what is KB? That's one thing for sure. You guys should recognize that the compound ammonia is a base. Okay? You should know that. Ammonia is a base. Okay? 0.950 molar solution of ammonia. That molarity, like we discussed yesterday, that given molarity of your weak acid or base, that is the initial molarity in the ice table. The pH will give us the equilibrium amount of what? It technically, literally gives the hydronium, but we can use that information to also get hydroxide if that's what we need. And that's what we need here. Because when we write, what kind of equilibrium are we writing? It's those things called acid or base ionization, or you can use the word hydrolysis. These are the equilibrium for writing, which is the weak thing plus water makes, remember this is a base. What are we going to make? I know we're going to have a hydroxide ion because this water is acting as the acid and it's donating a proton to the base. So what is the conjugate acid of NH3? NH4 plus. Very good. Okay, ammonium and ammonia. So ice table, initial is that given molarity. Guys, do we write anything in an ice table for anything that's liquid or solid? Never, nothing, never. Liquids and solids do not have concentrations. Is it correct to write a 0 here? No, the concentration is not 0. The concentration is nothing. Numbers. I mean, I guess if you were going to put anything, it should be a number 1. Okay? Concentration is 1 out of 1. Okay? But we don't, it's not a concentration. That's not the definition of a concentration. It literally has no number because it's not a concentration. It's not a mixture. It's a pure substance. Initially, over here, I don't have any. This is the thing that's going to change by getting smaller. Minus x. These are going to change by increasing. Plus x. Did I record? Yeah, okay. In order to calculate KB, right, I need to know these concentrations at equilibrium, don't I? I cannot calculate KB if I don't know these concentrations. How can I figure out what X is in this particular problem? Let's use the pH that was given to us. But pH would give me H3O plus concentration. I don't have H3O plus here. I have a base. I have hydroxide. So there's multiple ways you could do this. This is the way I see it. easiest, I think. Yeah. Because to me, it's very easy to remember, oh, if I do 14 minus this number, right? What did I say? 11.612. 2 point. Thanks, Joseph. Okay.
So that would be your X? No.
So that's POH. This is OH concentration. So I have to do, I have to undo this P logarithm function. So that is when I have to take my concentration and do 10 raised to the negative value that I just found. Okay. 10 raised to the negative POH will give me X. Gives me X. And what did I get for that? Right, my stuff is. .09 times 10 to the negative third. Somebody wants to just double check my math there. That's right. Yeah, okay. Okay. This is the concentration of OH minus at equilibrium. pH, POH is always based on concentrations at equilibrium. So if this is the value at equilibrium, then this is X from my table. And so I am solving for KB by doing X squared divided by 0.950 minus 4.09 times 10 to the negative third. Oh yeah, sure. I just wrote an X. But it is, sorry, I guess. Okay, I'll do that. Yes, you would use the number there. Yes. I got a KB of 1.77 times 10 to the negative fifth. Yes, good job, Joe. So this is what, I call a type 2. Because I'm given an initial and I'm given a way to find equilibrium and I'm calculating K. That's what I call type 2, right? Type 3, let's look at those. That's where you might have to solve a quadratic. Or sometimes you can make that assumption. Guys, if you make that assumption in your work, you need to write that you made that assumption in your work. Okay. If you make the X is small assumption, you got to write it somewhere. And you got to check it. You got to check when you make that assumption, check. It is real important in this chapter to check. Because there's going to be some times where it's kind of iffy. Like the K value and the initial are going to be kind of close. And you're like, can I really assume X is small? Let me try it. And then let me check the 5%. Okay. It's real important in this chapter. So, in fact, let's look at number. Is that the one I want to do next? Okay, 22. I don't have these on the slides. What the frick? There should be 23 and 24 and 25. I don't know what I was doing. No, it's on these, it's on mine. Okay, it's fine. Let's look at 22. Okay. So we got an acid. How do I know it's an acid? Ka. And what did I say the name of this compound is? What did I say the name of this compound is that we're looking at? Formic acid. Formic acid. That's this compound right here. Formic acid is what is in ant bites. That makes it sting when you get bit by a fire ant. They're injecting you with this acid right here. Yes, really. So formic acid is an acid. So when it does hydrolysis with water, there is the equation. Okay. And there's the Ka. What if I have 0.534 molar formic acid? So there's my initial concentration, 0.534 molar. And I gave you the Ka. What is the hydronium ion concentration when? I should have put the word here, I guess, technically. At equilibrium. We're finding hydronium at equilibrium because that is how we find pH. pH is using the equilibrium concentrations, right? Okay, so let's set up an ice table, right? Let's set up an ice table. What is this? 22. Okay. You guys, if some of these acid formulas, right? This is a pretty short one. That's fine to write. But you guys can always just shortcut the weak acid, just HA. That's fine. Okay, if that's what you want to do, you just do HA. That's fine. We'll talk about that later. Okay, if you were using the HA format, right, what would be your generic symbols that you would be writing over here? This would just be A minus. This is still H3O plus. Okay, you still have water and H3O plus. You can just shorthand HA for the weak acid and A minus for its conjugate, okay, if you want to. Five, 3, 4? Okay. It's going to decrease by X. Okay. How do we solve for X? We first write our K expression. And we plug in the variables, our X's from our table. What did I say the K was? 1.8 times 10 to the negative 4th. Okay, so I'm going to say let's make the assumption. Why? So this is on the order of 10 to the negative 1st. This is 10 to the negative 4th. I feel like that's a big enough difference between the sizes of these two numbers that I can safely assume X is small. Okay. So that means I'm going to ignore the minus X and just solve for X. So I'm multiplying these two numbers and taking the square root, right? That's how I'm solving for x. And I'm going to get 9.8 times 10 to the negative third. Okay, check your assumption. Check your assumption. How do we check? We take our x value and we divide it by whatever initial concentration I was given, times 100. Look at it as a percentage, right? If it's less than 5%, then this was a fine assumption to make. So 9.8 times 10 to the negative third divided by what? 0.534. .8% difference between x and the initial. And that is a fine value to make that assumption. That's okay.
So you're gonna make the assumption why then? Like how you know to make the assumption?
I look at the size of the initial, and if I think about it in scientific notation, so if I move this one place over, okay, that has an exponent of 10 to the negative first. My k value has an exponent of 10 to the negative 4. If the two exponents, right, your initial and your k value, if the exponents are more than 100 times different from each other, you can usually make the assumption. So if this was to the negative first and this was to the negative third, we'd be kind of close. We'd be kind of skirting it. We would definitely want to check. When they're that far away, it's probably a safe assumption, but we just double check to be sure. I think I got one where we can't make the assumption. Less than 5%. If it's more than 5% different, when you do the check, if it's more than 5%, you need to solve for x using the quadratic equation. Okay. I thought I had one where we. Okay, maybe I'm not listening. So a lot of times people get to this point and they're like, "Woo, I did it." What did I ask? What did I ask in the question? It's not okay to just give me this number. First of all, I said, what's the concentration? So that means when you give me this number, it needs to be molar with the concentrations, right? So that was one of the answers I asked for. And then this specifically said, also tell me what the pH is. So let's look at our sig figs. Our concentration has 2 sig figs, so my pH value needs to go 2 decimal places past the decimal point. What is that? 2.01 when it rounds bright. Okay. Good girl. Okay, this is the other one I want to do, and then I think I want to go to the next section. Open up the next set of slides. So let's look at I'll tell you guys 23 and 24 pretty much just like this. So is 25. Do you guys remember how to calculate percent ionization? Let me just, this question didn't ask that, but let me just show you real quick so you can do it on these other, so we've done it so you can see on these. So what if on number 22, I said, give me the percent ionization. Okay. You guys are gonna love this. You ready? Go look on your study sheet or back in your notes. How do you calculate percent ionization? Okay. The H3O plus concentration, the H3O plus concentration at equilibrium over the initial given molarity of the weak acid. Okay. I'm gonna make it. I'm gonna make it. Where's my dad? Okay. We got practice. What did Joseph just realize? What is the equilibrium concentration of H3O plus represented as in our table? Isn't that X? We know what X is now, right? What's the initial concentration of the weak acid? Oh, isn't it the same as what? Isn't this the same as the 5% rule? Yes, it is. Yes, it is. Yes, it is. We take our X, 9.8 times 10 to the negative third. We divide it by the given initial amount. And not only does this check, is our assumption okay, it tells us what percent this acid ionizes. This acid ionizes 1.8%. Does that mean it's a strong acid or a weak acid? Is it 100? Is it 100%? No, so it's weak, right? I told you guys, weak acids don't ionize 100%. That's proof. Yeah, this one barely does it, right? It's crazy. Let's look at one that does it more, but it's still quote unquote weak. So this is one I want to skip to. So like I said, 23 through 25 are repeats of this process. Acid, base, ionization, find X, okay? Let's look at 26 or 27. Should we do an acid or a base? Let's do a base. Let's do 27 then. I'm pretty sure I got all of this. Well, it's kind of worked out in here. Okay, I didn't. Okay. This is where I dropped off last night. It was like 2 o'clock in the morning, and I was like, I gotta go to bed now. So that's what I'm saying. I came home and I graded your test. And then I was trying to do more work because that's who I am. This is why my life is not in balance, guys. My life is not in balance at all. My life is a hot mess. Veronica, you know what I mean? Yup. This is caffeine. So I know I quite enjoy it as well. Okay, so again, this is where I had quit trying to fix the numbers. So this says 21, it's not 21, it's 26. This is 22, it's not 22, it's 27. This is the one we're doing right now. Okay. So do you guys recall me telling you that for these weak bases, we're going to see compounds like this, like caffeine, that we haven't been seeing? But how can you recognize if something is a weak base? You're really looking for if it's got that nitrogen in it. Just like ammonia, NH3, if the compound has nitrogen in it, guys, that's going to act as a base, okay? Always. Why you always want me to say yes, always? I think, I know. I would say that's a very safe bet in this class, yes. In all situations, all the time, for the rest, forever and ever, amen? No. Okay. But in this class, Catherine, for this, your chemistry journey right here with me, for your chemistry test right here with me, yes, this is a safe bet, okay? If it's got a nitrogen in it, and you're like, I don't really recognize that compound, it's a base, okay? Okay, it's a base. Okay, so If you don't feel like writing this whole formula out, what's our shorthand for a weak base? For a weak base, we can just write B. Okay? For a weak base, we can just write a B. Because it's going to take an H plus, right? So on the other side, then, we would just write a what? HB plus, BH plus, something like that. That's fine. Something like that, right? So. I'm all hopped up on Mountain Dew. Y'all are gonna miss me. This semester is over. I know. Caitlin, you ain't gonna miss me.
No, well, I was like wondering why you wrote B, and then I forgot that's what you just said.
Before I did my. Okay. We are fixing to take a break though, because apparently his code needs it. Apparently I need the break, John. I don't know what's going on with me today. Okay.
We should just gone home.
We should have just gone home. I agree. We should have taken a class trip to the coffee shop to get some caffeine and then sat in the coffee shop and worked this problem is what we should have done.
Yeah.
That's what we should have done. Next time. What is our initial caffeine? 1, 0 after the 1. Okay. Nothing for water. Nothing of these initially. Minus X. Plus X. Plus X. 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 Okay. What did I ask in this question? Let's find the pH. But obviously the first thing we're going to be finding from this is the OH concentration. And then we'll have to get to the pH from there. So I'm solving for X. Same as I did over here. I solve for X. So I set up my KB. This times this over this. So okay, so got X squared on top. On the bottom, I have 0.010 minus X. And what is the value of KB for caffeine? Okay, guys, here's a situation where that's 10 to the negative 2. That's 10 to the negative 4. We're skirting. I think we're going to be too close. But why don't we make the assumption first, and then let's just check the 5% rule before we go through the quadratic. Yeah, let's just do that first, because this is a fairly easy mathematical solving, right? It's the square root of 2 numbers. Okay, that's easy. So let's just try it. So let me assume X is small. God bless you. So if I do that assumption, then I'm solving for 0.010 times my KB value. And then I'm going to take the square root. Let's see what that gives me. I don't actually.
The opposite would be the same.
Yeah. Because multiplication is, what's the word? Communicative. Is that right? Communicative. Communicable? It doesn't matter what order you multiply them in, you get the same answer. Convoluted? I think you're correct. I think it is too, but I always kind of forget what that word is. So I should be times 10 to the negative 5th now, right? But I mean, 6. Oh yeah, and then square root. 2 sig figs. Okay. So when I check, let me just write my check. %. Ah, that's why. Okay. Bad assumption. Badass, okay? Badass. Bad assumption. So what do you gotta do? We gotta solve a quadratic. Did you figure it out for your Scarlet? Okay, let's see if I can figure this out.
It's not even valid. Yeah, so, okay, then so you multiply that and okay.
So I wanted to say to you guys that it's totally fine with me if you want to show me, if you have to solve a quadratic and you want to show me your work right now, that's fine. I'm more than happy to look at it. I do it for myself. I don't know that that's something that you have to do for me. Like, show me how you got it all out. This isn't math. I know this isn't math class. I mean, it feels like it is, but it's not math class, and so I don't need to necessarily see that work written out if you don't want to write it. Okay. If you want to write it, feel free. This side. What did I do?
I got e to the negative 6.
Yeah, it's yes, yes, yes. I'm sorry. Yes, you're right. Yes, 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 yes. My bad. Okay. So A is 1, B is 2.5, it's 10 to the negative 4th, and C is negative 2.5 times 10 to the negative 6. Okay. Okay. And now we'll solve for X. Okay. Oh my gosh, quadratic. How I love you. I know. Okay. Damn it, why did I just hit that? I think that's what. Plus. Okay, so one of my answers I got 0.00146, but we would round it to 0.15. And then what was my negative root? Do you get a negative number?
Mm-hmm.
If you do the negative, okay. Yeah. Yeah, the other x solution is negative. Never. Because if I'm saying x is a negative number, that means I'm saying there's negative concentration at equilibrium, and that's not a thing, right? It's not a thing. It can be 0, it can't be negative. So we'll use this as our molarity of what? This is the molarity of OH minus. So pH, or rather POH first, because I think this is the easiest way to solve it. pH is negative log hydroxide. So that's negative log of 1.5 times 10 to the negative third. Two something? Mm-hmm. 2 sig figs, 2 decimal places, right? So POH, 2.84. So pH, basic solution. $11.16. Yes?
Do you have to turn that into scientific notation?
No, I just did it for space. No, you don't have to.
I got 10.82. I'm not giving the X.
You didn't get X here?
I didn't get 15. I
What?
got 17.
Oh, I don't know.
But I put in the same numbers as you.
Yeah?
In the calculator. Why am I not getting a 15?
I don't know. Let's here, we're gonna take a break. Oh, I also got 8 too. I don't know. Whatever. I got 8. I got 2.82 also. So 11.18. Perfect. There's the answer to that whole problem. 2 points on the test. Yeah, cool. Yeah. Multiple choice question, 2 point multiple choice question. Yeah, on the final it would be 2 points. Okay, let's take a break, and we're gonna come back and we are gonna open up the next number set of slides, lecture 12 slides, and we're gonna start that new packet, the part 2 packet. So if you didn't grab that yesterday, today's the day.